Hello and welcome to today's lesson where I will show you how to balance chemical equations. There are three different ways how you can balance chemical reactions. The first one is for people who just learning how to balance reactions, and we'll be talking about this method in this lesson. The next one is called the oxidation reduction. And lastly, we have university level redox method. Before we start this lesson, be sure that you know how to count atoms in the molecules. I made a video about it, so I leave a link at the top right corner. Now, why do we need to balance reactions? And when do we need to do this? Well, the idea of balancing reaction is to have the same amount of atoms before and after the reaction of the same element. So for example, we have a reaction in which water is produced. Hydrogen reacts with oxygen and we get water. If we look at our reaction, we have same amount of hydrogen atoms before and after the reaction. In both sides, we have two atoms. Now what about the oxygen? We have two atoms of oxygen before the reaction, but only one after the reaction. And because of that, we need to balance the equation using numbers which are called coefficients. We can only write coefficients before compounds. For example, what happens if I write coefficient 2 in front of water molecule? Coefficients change the number of atoms present in the reaction. All we do is multiply atoms of hydrogen and oxygen by a coefficient. In this case, it's 2 times 2, which is equal to 4 for hydrogen and 2 times 1 for oxygen. So now, after the reaction, we have 4 atoms of hydrogen and 2 atoms of oxygen. Note that after we wrote the coefficient, we got an equal number of oxygen atoms, but also a number of hydrogen after the reaction increased to 4. Now, if we write 2 before the hydrogen molecule, we also get 4 atoms of hydrogen. And at last, we have same number of atoms of the same element before and after the reaction. So remember, we use coefficients to help us balance the reactions. And also, do not forget that we can only write them before the compounds. Let's look at another example. When aluminum reacts with sulfur, we get aluminum sulfide. Once again, first let's look at how many atoms we have before and after the reaction. For aluminum, it's 1 and 2, and for sulfur, it's 1 and 3. To balance the equation, we need to use coefficients. You always want to write the coefficient in front of the element with the smallest number of atoms. In this case, it's aluminum and sulfur before the reaction. Because I have 2 aluminum after the reaction, I need to write coefficient 2 before the reaction. And now I have equal number of aluminum atoms. The same goes for sulfur, but instead of 2, I write 3. Now we have the same amount of sulfur and we balance reaction correctly. Let's do one more before we go further. In this problem, chlorine reacts with oxygen and produces chlorine 5 oxide. Like in the last examples, we count how many atoms of the element that are present. For chlorine, we have 2 before and 2 after the reaction. For oxygen, we have 2 and 5. Let's add some coefficients for this reaction. Because chlorine has an equal number of atoms, we of course start with oxygen. And remember that you start with the side where is a smaller number of atoms. All we need to do is to decide what coefficient we want to write in front of the oxygen. If I write 2, so then we have only 4 atoms of oxygen, which is too low. But if I write 3, we have 6 atoms of oxygen, and now the number of atoms is higher than we need. There is a trick you can use in this and similar situations. You swap subscripts with coefficients. Let me show you how you do that. Subscript 2 goes as a coefficient for Cl2O5, and subscript 5 goes in front of the oxygen. Now what we get is 10 atoms of oxygen in both equation sides. Note that after we wrote coefficient 2, not only number of oxygen changed, but also chlorine increased from 2 to 4. So now we need to balance chlorine before the reaction, and coefficient 2 should do the job just fine. And now we have a fully balanced reaction. Let's do a few reactions with more compounds involved. For example, hydrogen chloride reacts with potassium and produces potassium chloride and hydrogen gas. Like always, let's look at how many atoms of each element we have before and after the reaction. 1 hydrogen before and 2 after the reaction, and on both sides we have equal number of chlorine and potassium atoms, which is 1. So we only have an unequal number of hydrogen atoms. So we need to write coefficient 2 in front of HCl, and now we have 2 hydrogen atoms. But when I do that, notice that number of chlorine atoms changed as well. Now we need to balance chlorine, and we can do it by writing 2 in front of KCl. And lastly, because the number of potassium atoms changed to 2 after the reaction, we write coefficient 2 right here. And now the equation is completed. Let's look at the last example, where calcium nitrate reacts with sodium carbonate to produce calcium carbonate and sodium nitrate. Let's write how many atoms we have. There is 1 calcium atom, 2 nitrogen and sodium atoms, 1 carbon atom, and 9 oxygen atoms before the reaction. After the reaction, we have 1 calcium, nitrogen, sodium, and carbon atom, and 6 oxygen atoms. We start balancing the chemical reaction from the lowest number of atoms. In this case, it's either nitrogen or sodium after the reaction. Either way, we must write coefficient 2 in front of sodium nitrate. What's changed? Now I have the same amount of sodium before and after the reaction, but also same goes for nitrogen and oxygen. And now we have perfectly balanced reaction. Thank you for watching this video. Do not forget to subscribe for more chemistry content, and let me give you a few exercises that you can try yourselves. Pause the video because in a few seconds I will show you the answers. And here's the answers.